All right, so most of these questions are not asked in a straightforward fashion. So what happens here is that you need to, you need to find a method that's suitable for you. Remember, I said that if it's more than 5, usually you want to rely on binomial theorem, not the Pascal's triangle. So already this limits you to binomial theorem. Okay. So now they're saying find the independent term in this one here. Now, what is the independent term? That's what we need to understand before we answer. So independent term means that you don't have any of the variables attached to the coefficient. So it could be like if you have 1 plus x squared plus x3, right? The independent term will be this one because it doesn't have any of the variables. Okay? So this is something that we need to understand, right? So now we're looking for, essentially that means that it's called the variables power 0, right? So we said binomial theorem works off the formula. For example, here it would work off the formula. Okay, it works off the formula n, r. Okay, I like to use r. Then we have a here, right? Then we have n minus r, because this is the one that reduces. So this helps. Subtraction reduces things. So here we should know that it's reducing. Then we know that this one is going to be increasing. So r, because r is our counter. So it's 1, 2, 0, 1, 2, 3, from 0 to n, right? So this is something that we need to remember. So this is the term itself. Whenever they tell you to find the independent term, whatever, it means that they just want you to work with one of these. All right, so what can we already get from here? We can simplify this to say it's 8r, okay, because n is 8, right? Then we have a. What is a? A is going to be our first term there, which is x, okay? So x, we're going to power it to 8 minus r, because we know n is r, n is 8, sorry. And then we are looking for b. B is going to be this whole term here, because normally we say it's a plus b. So for these to relate, this has to be with that, then this has to relate with this whole thing here, right? So b is going to be 1 over x, but with the negative sign. Okay, so now what will be the power here? The power is going to be r. Okay, now they're asking us for the independent term. If you checked our earlier videos, we had looked at simplification of exponents. So you need to now focus on these two, right? So I will just be repeating this so that we don't drop any terms out. So this one is going to maintain that, but I need to simplify this. There are several ways in which we can simplify this, but the one that is going to be helpful is if I take this and I take it inside here. Remember, we did some simplification like this where we said if you have, let's say you have x here, okay? I think we had used n. If you have n here, it's going to be a n over b n, like that. So it's the same concept here. We're just going to do the same. We're going to have minus, we're maintaining that. Then this is going to be like that, power r over x power r, like that. Okay, now here we can exclude this one, okay, because this is the same as 8. I need to be careful here and show all the details. So 8, like that. Okay, then we can say that this is minus 1 power r, so that we don't lose the negative, right? And then we have this one here, which is 1 over x power r, right? So I can get these two terms together. Okay, so we can say 8r. Notice I'm not just getting the ones I'm interested in. I'm actually considering all the terms each time I write, okay? So here it's going to be 8 x, okay? This is going to be x, like that. Then we are saying it's 8 minus r. Then we are saying this is going to be divided by x r, like that. So now we can do it one last time, 8 r, like that. Then we can have our minus r, right? And then we can continue with our simplification here, 8 minus r. But we say that if we are dividing, it's the same as subtracting the powers. What powers have we subtracted? 8 minus r, and then we've subtracted r there. You see? So now here we're going to have 8r like this. We maintain our minus 1 for r. And then here, what do we have? We're going to have x8 minus 2r. Now I've got my x term, independent of the other terms. So what is the secret here? We were saying that this needs to be, it needs to be removed, the x. So it needs to be a 1, not a 0. This needs to be a 1. When do we get 1? We get 1 when x is power 0, right? So we can simply say now that 8 minus 2r is equal to 0, right? We must be masters now at this, so we can say 2r is equal to 8, hence r is equal to 4. Okay, so now we know that the coefficient here, so now we can expand this. This is going to give us 8, 4, like that. Then here we're going to have minus 1, 4. And then here we're going to have x, right? X, 8 minus 2 times 4 is 8. So we can simplify this further. This gives us positive 1. This gives us 1. So our independent term is going to be 4. You might be asking, why did I go through this here and there when I know that this is 1? And sometimes this can be negative 1. Sometimes this can be 2. When it's 2 power 4, the value of this is not just going to be this. It includes the value that's coming from these other numbers. So now we can see that this is our value here. So you can either put that in the calculator if they allow you, or you can calculate this. This we checked in our last video. It was like this. And then here we said that we're going to use r and then n minus r, which is 4. So this can be simplified into 8, 7, 6, 5, then 4 factorial. So I do my 4 factorial here. And then the other one, I'll reduce it. Okay, I'll explain why. This one, I knew that I can use it to get rid of this. But this one, I no longer have 4 factorial. So I have to expand it the way it is. So I take this and that's 2. The 2 and that, they go away. So I've got 1 left here. Then the 3, I can take it into here. I get a 2. Right. So what do I have remaining? I've got a 7. I've got a 2. And then I've got a 5. 5 times 2, that's 7. That's 10 times 7. That's 70. So my independent term here is 70. Right. So this is how you solve this. You have to be very good at simplifying exponents. And then you have to be good at expanding this to get your answer. But the most important thing in here was for us to understand the term. What does it mean to have an independent term? Okay. Then also, what does it mean, okay, to simplify an expression like this? Can you simplify an expression like this? If you can't, the videos that we did for simplification and the other videos on YouTube, the internet, where you can simplify exponents. It's a very important concept when it comes to this. Okay, let's look at another example. This is another example, the first test. Find the term in the expansion of 2x minus y power 3, right? So what are we looking for here? What we're looking for here is the third term, okay? The third term in this expansion here. Now, what's the trick here? The trick is knowing the number to use, because this is not an algebraic number. This is just a statement, right? So we need to change it into a number that we can use here, right? So what is the third term? Let's go back to the first principles. We said that we count the terms like this. This is a counter 0, 1, 2, 3, like that. So what is the third term here, right? So the third term is going to be first term, second term, third term. Have you seen? So again, the third term is not actually 3 in terms of R. It's actually 2. But what's the relationship? The relationship is this. Nth is equal to, in this case, we're using R as the counter. So it's R plus 1. Okay? So here, if we want to get R that we're going to use in this step, because remember, we're looking for the third term. How do we calculate it? We need to, here we know already the expansion is 3, which is N is 3. And then R, we don't know what it is, right? We're looking for the third term. So then we are expanding this. We're going to say this is going to be 2x. Okay, that's the first term. This is N minus R. So N is 3, you know, 3 minus R. And then we look at B. B is going to be minus Y. Power what? Power R, whatever the value of R is at that point. But then how do we, you see that R is our hindrance here. How do we get R? So whatever they've said, if they say third term, on nth, you're going to use that same number. So it's going to be 3 is equal to R plus 1, right? So R is equal to 2. So for the third term, R is equal to 2. Or the counter, in our other example, we said K, which is equal to 2. It doesn't matter. Okay? So now here we can say 3, 2, and then we have 2x, 3 minus 2, and then here we have y power R, which is 2. So now we are on our way. There are two things that we need to know. The first is how to expand this. We say that it's going to be 3, like that. And then we are going to say R, which is R factorial, which is 2 factorial. And then in our brackets here, we're going to have N minus R. So 3 minus 1 minus 2, which is 1. So we're going to have 1 factorial here. Okay. So now here we're going to have 2x. Then the power is going to be 1. Here we're going to have minus 1 minus y. The power is 2. Okay. So now, what else can we see here? What else can we see here? We have got 3 factorial. We have got a 2, and then we've got a thing here. So let's continue. So 3 factorial is 3 times 2 times, in fact, I like to do it this way because I know I'll have 2 factorial here, like that. Then here I have 2x, and then here I have y squared, because now this becomes positive. Right, what else can we do here? We can cancel this and that, meaning that these two can multiply. So we're going to have this and that is 6. Let's put it here. So we continue here. This and that is going to be 6x. And what about this one here? We cannot forget about it, so it's pi squared. So this is the third term. in our expansion. All right, so let's do one last example. Final example for binomial theorem. Okay, that is for integer powers. Okay, we're going to look at maybe negative and fractions here in the next chapter. But for now, we are going to try and solve this. So they're asking us for the independent variable here. I'm using independent because it's a little bit difficult sometimes. So I want us to become good at this, right? So we said that we are going to use the formula NR, and then we say that we use A, which is the first term here, N minus R. Why? Because this one reduces. Then we recognize B as increasing, so the counter is going to be on B. Okay. So how do we simplify this? We say 18, right? Because that's the N. And then we say R. We don't know what R is. And then we are going to say 3x, right? Power 18 minus R, right? And then here B is going to be 2. You have to collect everything. So here, okay, x squared. And then the power is going to be R. R, again, we don't know what it is. So here we're going to begin our expansion. So here, multiplication, remember, AB, power n. We said that it's A, N, B, N, right? So here we're going to say 3, 18 minus R. That's the number part. And then we get our x, 18 minus R. Then we're multiplying with this. Again, our R goes in. Now, this time around, I'll get the negative to be on 2. So, like that. Okay? So, I'll put it with R. This one is going to be on this one. So, I'll say X. These powers are going to combine. So, we have 2R. I've done most of my separation. There's still more that we can do. So, we're going to say 18R. Like that. Let's put all the constants together. So let's choose the constants. This is a constant. I think this is a constant as well. So I'll say minus 2 power R. Then the variables are going to be together. So it's 18 minus R over x 2R, like that. So I can subtract these two. So to say 18 minus, because now I'm trying to create my independent, which means that this needs to equal to 0, to 1, meaning that the power has to be equal to 0. So this is going to be R minus 2R is equal to 0. What have we done here? We've subtracted the two powers here. Why have we subtracted? Because we say that if A and B are dividing, it's the same is if A and A, rather, if A and A like that, they've got the same base, then we can say that it's the same as M minus N, right? So you see that we have that. So simplifying this further will give us, this is minus minus minus, so 3R is equal to 0. Okay, solving for this, therefore, we can say that R is equal to 6. Okay, R is equal to 6. Right. Now, if R is equal to 6, what does it mean? Now we're looking for this, because we know that this is going to give us 1. So we shouldn't even bother, because here, 18 minus R, that's what? That's 18 minus 6. That's 12. Here, it's going to be x power 12 as well. So this gives us 1. So our focus is this constant, the independent variable, the independent term it's just the constant, this constant. So we have 18, 6, like that. Then we have 3 power 18 minus 6, which is equal to 12, right? Then here we're going to have minus 2 power 6. Okay, so already this is an even number, so this becomes positive. We'll know that after we work it out, it will be positive. So this is not something that you can do with multiplications. It's complicated. It will be a lot of numbers to do. But estimating with the phone or calculator, we get 6.314 times 10 power 11. It's rare that they'll ask you to simplify this any further. At the least, maybe they'll say that you simply put it in order like I've done here. So for example, maybe you can say 18, 6, you show that. Then you can say times, okay, 3 power 12, then times 2 power 6. That's it. It's enough. Okay, you don't have to show this unless if maybe they've allowed you to use calculators, but this is enough, right? So this is how you get the independent term. We'll look at more examples as we go. Please share and subscribe. All the best.